All right, well, what we have here is now we're going to finish up simplifying trig ratios, okay, and or trigonometric expressions. Yes, these are ratios because they are division, and we're going to simplify these by trying to eliminate the denominator. Okay, so we're eliminating the denominator in all three of these expressions. So to do that, okay, one of the key things is we want to get rid of the denominator. So to do that, what we're going to do is either A, we can multiply by the conjugate of the denominator, or B, we can look for a trigonometric expression that will allow us to simplify it. All right, so a bunch of different ways you can do this, all giving you kind of the same kind of answer. Well, first off, right here, what I would do with this one is I see sine squared y, sine squared y. Now, sine squared y, if you recall, all right, and we have 1 minus cosine y. Well, this kind of gives me pause, all right, because what we have right here is this is sine, all right, squared y plus cosine squared y is equal to 1. And if I have sine squared y I know is going to equal 1 minus cosine squared y. Now, another thing that if you didn't know, is that this is a different square. So we can do is actually take 1 minus cosine of y. This times 1 plus cosine of y. And that will give us that expression right there. Well, seeing that, this all equals sine squared of y. And if you have this, all right, and you can replace that, well, notice that this and that are the same. So that is y. We're going to go right here, and I'm going to just take this sine squared y and replace it with the top. I'm just going to have 1 minus cosine y times 1 plus cosine y, because I know that comes from 1 minus cosine squared, which comes from here. Hopefully you can see that, and that's where I'm replacing this with that one right there, so if you're following at home. All right, so now I have 1 minus cosine of y, and you should realize that now, hey, these cancel out. And we're left with, in our final expression, our simplified expression of 1 plus cosine y as our simplified expression. And that's it. All right. So in this one, I looked at sine squared, and I realized that doing this enough that sine squared is going to equal 1 minus cosine squared, and that can be simplified into these expressions, and that I knew that could cancel out. Now, this other one, number 14, is a little bit more complex. What we have is secant squared minus tangent, not secant squared, but secant x minus tangent x. Now, unfortunately, we can't use any of these trig identities, all right, because we always need a square. Okay, if you notice, there's always a square involved, and these don't have any squares. This one doesn't have a square, so I couldn't simplify this one, but this has a square. This one doesn't have a square, but you see this one has a square also. So all those I could maybe use a trig identity. Now, how can I create a square? Well, one thing we could do is when you have a quotient like this, is what I would do is normally I would probably multiply by the conjugate. Okay, I would multiply by the conjugate. So top and bottom, I will multiply by 1, all right, and the conjugate of whatever the denominator or whatever this expression is, okay, this binomial. So what we have right here is I'm going to multiply this by secant of x plus tangent of x. And I'm going to multiply this one on top by secant of x plus tangent. I have to do that because we cannot just multiply just the bottom. All right, that's illegal. We have to multiply this expression by 1. That is legal because there's always a 1, all right, next to any expression, and that's why we can do this. Okay, so in doing so, what I create is I have 3 secant of x plus tangent of x. Probably want to put some brackets or parentheses in here. We'll put a little bracket right there. Now, on the bottom, what I have is I created a conjugate. So now when I factor this or distribute it through, that is, all right, what's going to happen is I'm going to have secant times secant, which is going to be my secant squared of x. The middle terms, because these are differences, 2 squares, they're going to cancel out, and so they're going to cancel out. But now I'm left with minus tangent, all right, squared of x. Okay, so now when I have this, what's going to now happen is I want to try to get rid of this denominator of some sort. Okay, well, we know one of the trig identities has secant or tangent in it. And if you recall, I'm going to write another one out. If I take this, and I'm going to get secant, well, if I take this expression, and I always think about it, dividing it by, all right, 3. So if I had, like, once again, sine squared of x plus cosine squared of x equals 1. If I divide it by cosine, divide this whole thing by cosine squared, what I'll have then is tangent squared of x. It's going to turn to plus 1. And then what I have is 1 over cosine squared, which is going to turn to secant squared. And that's what I want. So secant is actually equal to tangent x plus 1. Well, that, I think, is what I'm going to use. All right, I'm going to take this. I usually look at the positive portion because it makes it a little easier. So I'm going to take this expression, all right, tangent squared of x plus 1, and replace that for my secant, because I think something good is going to happen when we do that. So what happens then is my top, I still have 3 times the quantity, secant of x plus tangent of x. And that's going to be divided by, all right, I'm going to replace that into here. So now I have is tangent squared of x plus 1 minus tangent of x, squared of x. And now you realize that, hey, this is a positive tangent squared. This is a positive tangent squared. This is a negative tangent squared. These will cancel out. I'm left with 1 here, which is over here. And that, my friends, is where we are finished, as it would say. And we would have our final answer of 3 times secant of x plus tangent of x. We got rid of the denominator. We simplified our expression. That is our final answer. Bada bing, bada la boom. And that's what they say. All right. So once again, using fundamental Trig identities, it helped us simplify this and getting our answer there. Now, I'm running out of room, so I'm going to make this, and I don't feel like making another video just for one problem. So I'm going to bring this in the bottom. Extend out this page a little bit. I'm going to do this one right here. Okay. And here we go. So let's try this one now. All right. So we have tangent squared and secant x plus 1. All right. So using what we've known before is, yes, we know that, if we recall, tangent. All right, we have this expression, and maybe I'll bring it down here, okay? Because we're going to use this because I want to get rid of cosecant x plus 1. Now, to do this, all right, I could maybe get rid of this and put secant, but I want to get rid of the denominator, and I'm going to see if we can multiply the conjugate because there is no secant, or sorry, cosecant in with tangent, correct? Hopefully you can see that. So for that reason, because there is no cosecant with tangent squared, I'm going to actually multiply this one by the conjugate, all right, of the denominator. So I'm going to multiply this by cosecant of x minus 1. And top, and cosecant of x minus 1. And what we get then is this is going to simplify to tangent squared of x times the quantity cosecant of x minus 1. And on our bottom then, what we have is this is going to turn into cosecant squared of x, all right, minus 1. Okay, cosecant squared of x minus 1. Now, with that, all right, we can also, we have another trig identity. Okay, we have another fundamental trig identity. And that also we can find by dividing, all right, up here, if you recall, I divided here by cosine. I'm going to divide this whole thing by sine. Now, when I divide this whole thing by sine, all right, I get 1. All right, that turns into plus cotangent squared of x. Divided by sine, I equals 1 over sine squared is going to be cosecant squared of x, and we have that. All right. Now, knowing this right here and having this other fundamental trig identity, now if you don't understand how I'm doing that or you're not figuring out, just memorize these and you're good to go either way. But I have this pretty close, but right there I have a 1 plus, and I need a minus 1 over there. So guess what we're going to do? We're going to do a little algebra. I'm just simply going to take this negative 1 right here, and I'm going to subtract to the other side, minus 1, minus 1. And so what we have then is going to be this. Cotangent squared of x equals cosecant squared of x minus 1. And that is what I want, because I'm going to put in cotangent squared in there now. When I do that, hopefully you're following. So I'll still have tangent squared of x. I'll have cosecant of x minus 1 still on top. I will now have, I'm going to replace this expression all right, which is the same there, with my cotangent squared. So that's why I'm going to have cotangent squared of x right there. We have that. Now, tangent squared over cotangent, if you don't know, all right, go back to green. These are reciprocals. Tangent of x equals, all right, or actually cotangent of x equals, all right, and that equals cotangent of x. So that means if I have tangent of x over cotangent of x, that's the same thing as having, all right, cotangent is the same thing as having 1 over tangent. All right, 1 over tangent. All right, those are going to be the same things. So if I want to take this right here, this actually can be rewritten and placed as this, because this right there, if I take the reciprocal of that, will turn into tangent squared. So actually, tangent squared of x times quantity, once again, cosecant x minus 1. This in the bottom is going to be 1 over tangent squared of x multiplied by the reciprocal. And so I now have a final answer. Move this down a little bit. All right, I don't know why I have that there. I apologize. Let's get rid of that. And so I have a final answer then of tangent to the 4th x, because tangent squared times tangent squared, times the quantity cosecant of x minus 1. And there we have it. All right, got rid of the denominator. I now have an expression. It appears to be pretty simplified. Tangent will not give me cosecant where you can't simplify it through. And that seems to be where we're going to be at. All right. So with that, many different ways of doing this, many ways of getting the same thing. However, key thing is conjugates allow us to get rid of the denominator of trig metric functions. We do that repeatedly in each one of these. Oops, one. Sorry. All right, right here. And that is where we can simplify these different expressions. All right. Well, I hope this helps you out. And check out some of my other videos to help you out on some other math help. All right. All right. Good luck and God bless.